Hello, in this video we will talk about using t-test for the population mean. So we know if we have a population normally distributed or at least approximately normally distributed, then we want to test the population mean, and if we know the variance and we get the sample size relatively larger than 30, then we can use normal test or called a z-test. But when the population variance is not known and we have relatively small sample size, so in this case we have to use t-test, so related to t-distribution. So if we look at this test statistic, which includes the sample mean, and this is the population mean we want to test. So we just assume in the null hypothesis that the population mean equals to this value mu. Then we get the sample average and sample standard error, then divided by the sample size square root. So this statistic follows t-distribution with n minus 1 degrees of freedom if the null hypothesis of this mean value is correct. And this is the calculation of the sample variance. So we take a square root to get the sample error. If we look at these three probability density curve, each comes from the t-distribution, and for small degrees of freedom, this curve is relatively flat and with the longer and the tail on both sides. But when the degrees of freedom becomes very large, say over 30 at least, then the t-distribution will comes to a normal distribution. So this is why we say if the sample size is very large, we can use normal distribution, and the sample size is small, we have to use t-distribution or t-test for the population mean. And this is the table for t-distribution. Usually we want to test t-test. To do t-test, we have to define an alpha level, for example 0.025 or 0.05. Then we get sample statistic t-value here, and if the t-value returns the probability on the right side is smaller than the alpha level, then we will reject the null hypothesis that the population mean equals to mu, right? And this table can get the t alpha critical value for different alpha level. For example, alpha 0.05, and we have 12 degrees of freedom, then the t critical value is 1.782. And on the other side, if we have calculated the t value, for example, we get t value 2.179 and the degrees of freedom is 12. Then we can get the probability on the right side of this value is 0.025. Then we can compare it with the predefined alpha level. If this probability is smaller than alpha, then we will also reject the null hypothesis that the population mean equals to mu. So next we look at an example. The chemical engineer claims that the population mean yield of certain batch process is 500 grams per milliliter of raw material. To check this claim, if this is correct, we take 25 sample, and if the t-value computed falls between t minus t 0.05 and t 0.05, then he is satisfied with this claim. Then we get to the sample x bar equals 518 grams, and the standard deviation of the sample is 40. So what's the conclusion the engineer will get from this sample? So here we first will find the t critical value associated with this level for alpha. So if we look back here, alpha 0.05 on both sides. So this alpha will be found from 24 degrees of freedom for the t level, t distribution. Then we find 0.05 and 24 degrees of freedom located here. We find that this value is about 1.711, right? Because we do not show all the degrees of freedom. So 1.711 for this t value, for the t 0.05 for 24 degrees of freedom. And from the sample size, we have 518 and 40 for standard error. So we can calculate the test statistic using 518 minus 500, then divided by the standard error divided by its sample size square root. So this value is 2.25. So as this value is much larger than 1.711, so this is the critical value associated with 0.05 alpha level, and we get the sample statistic 2.25 almost here. And this will return the very small probability on the right side actually is about 0.02. So we will reject the null hypothesis that the population equals to 500. So actually from the sample size we have strong evidence to conclude that population mean is significantly larger than 500, right? So this is the test or t-test for the population mean. Thanks for watching.